This question's about energy and about a pendulum. And actually, this question is an interesting one because I can jump to the answer very, very quickly, but then it's taken me a lot longer to actually think about how best to explain the answer. So we'll see how I do with that. With a pendulum, and we're interested in this displacement from the equilibrium position. So with the pendulum, this displacement from the equilibrium position would be something like that, where that's your equilibrium position. And it's how does the energy vary with S? What we'd suggest, or I'd suggest looking at how the question is set up, that the potential energy, gravitational potential energy at this point, we would say we can assume is zero. And then at any position not at the equilibrium position, the potential energy is greater than zero. So this exchange between kinetic energy and gravitational potential energy is happening all the time. And when the pendulum returns to the center, to maximum kinetic energy, so when it's in the equilibrium position, maximum kinetic energy, makes sense for it to set the potential energy to be zero. Right, the pendulum itself actually moves in an arc. And although we make a small angle approximation, it's actually moving in the arc of a circle. At small changes at this point, small changes to S here do not give a very large change to the height, and therefore do not affect the potential energy very much. So a reasonably big change in S here doesn't make much difference to the height, therefore doesn't make much difference to the gravitational potential energy. And this is where I'm getting onto this idea of why is it nonlinear? So I know it's nonlinear, but it's then sort of trying to explain why is it nonlinear. If I then look at this point up here, which is an extreme, but often extremes are a good way of getting you to your answer, a small change in S here, a small change in S, so I call that delta S, that's what we'd stand to. A small change delta S there gives you actually a big change in height. Therefore, a big change, so delta GPE is large here. So that would indicate to me that this is clearly nonlinear. So the easy bit is the fact that at zero, the potential energy is at a minimum, and then it's nonlinear. So the only example of a graph that gives you a zero when S is zero and nonlinear is D.